Hey everyone, it's really great to be here with you today. I am dialing in and have recorded this all the way from London, UK, and I really hope that everyone has been and will continue to enjoy all of the sessions from today's conference. My talk is titled Learning to Fail, subheading An Introduction to Test-Driven Development. I'm really hoping that we'll all walk away from this session feeling that failure is, or at least can be, a good thing. To tell you a little bit about me, my name is Siobhan, and I am a software crafter with a consultancy called 8sight. What that means day to day is I do full stack development, providing software services for clients. Community is also really important to me and has been a major part of my journey into a career in tech. And I'm really proud to be part of Coding Black Females, which is a nonprofit supporting Black women either working in or aspiring to work in tech. We do have quite a lot of online virtual events happening between now and the end of the year and into next year. So feel free to take a look at our upcoming sessions and sign up for any if they look interesting to you. Now, I mentioned that I'm a software crafter, but I've only been programming professionally for just under 2 years. Prior to switching into tech, I was working in community management and education. And that was until I found a 3-month internship, which I applied for, and took quite a big leap, a massive risk, hoping to transform my career. Really certain that I wanted to move into tech, but not without a little bit of fear about what comes next. As described by my talk title, we're talking today about failure. And I would like to ask you to think about the following question. If you had to fail in order to start, would you do it? Now, maybe some of you, like me, will have grown up with the narrative that you needed to work harder or that you didn't have as much space to slack off or not put all of your effort into something because there weren't as many forgivenesses available to you. You might even have been encouraged, whether it's by family members, peers, friends, into particular careers, which seemed more financially stable, both in terms of pay and industry and having a lifelong career. I personally, growing up, had a very clear sense of what failure looked like and quite a strong steer away from anything which looked like that. I grew up in a family that had a really clear and strong work ethic, and it was very apparent to me. And when I got to 18, a sudden change in circumstance meant that overnight I had to be self sufficient and that I felt that fear of failure even more strongly. And this fear has magnified each decision that I've made about my career going forward and been a driving force towards not getting things wrong because I only had myself to rely on and to provide for. We'll talk a little bit more about this relationship with failure as we explore test driven development. In today's talk, we'll cover what TDD, test-driven development, is and why we test drive our code. We'll look at a brief example of it in practice, and I'll also share some suggested resources. So firstly, thinking about TDD. What is it? Why even do it? Test-driven development is a philosophy which promotes writing tests first and then writing the code that's necessary to pass the test that you've written. And there are a few rules with TED. Um, for the purpose of today's talk, although there are different kinds or levels of tests, we're going to look specifically at unit tests. And with unit tests, there are typically 3 rules, but I prefer the amended version, which has 2 rules, and I've paraphrased them here. The first being only write enough of a unit test to fail. Your unit test should be small and I should really test one thing, one behavior. And you should only write enough code to then make that specific unit test pass. And to add to that, it shouldn't break any tests that you've written previously. Now, as I mentioned, there's different levels of tests. And if you want to look into those a bit more, I'd recommend looking up the testing pyramid. But if we think about unit tests, It's referring to when you break your program up into small, isolated units and write tests that ensure that each unit works as expected. And if we were to talk about something like a pair of glasses, imagine that as a program. The units you might have within your program would be the lens versus a unit for the arm. Now, although they're all part of the same program, a lens has a very specific type of behavior that's different from the behavior of an arm. And you would test to make sure that the arm is doing what it should and the lens is doing what it should. And why would you test drive your code? The idea behind TDD is that it will make it easier to be sure that your code is doing what you expect it to. Some of the specifications for how your program should work will be detailed in your tests, and by those tests passing, they're confirming that your program is doing and behaving as you expect it to. It can also help to keep your development quite controlled and quite concise. As we said, we write a small test first, and we only write as much as we need for that test, and then we only write as much code as we need to make that test pass. It also makes it much easier to extend your program over time with much more code safety. As you bring in a new feature, you add new functionality to your program, you can write a test around what behavior that's introducing and be sure that it's adding to what you have and not causing damage to what's already there. It has the additional benefit as well that it can be much easier to detect when things go wrong and do so much earlier. If you're running your test suite as you code and as you program, if there's a problem, you'll know it much sooner than if you don't test and maybe don't find that out until you go live and have your code in production. And if there is an issue later on in production where something might have changed, tests could potentially help to narrow down where that problem might be occurring and help you figure out where in your code you need to look at that. And if you think about an organization that might have a system that's been running for 10 or 15 years, you can see how valuable it is to have something within your code base, i.e. your tests, that helps you kind of narrow down where the problem might be and where you can start looking at how to fix that. So we've talked a little bit about what TDD is and why we might do it, and really understanding that test driving your code starts with a failing test first. Now we'll talk a little bit about how we do that and one key fundamental in how we apply test-driven development. And that's the red-green refactor cycle. So as we mentioned, we first will write a red test or a failing test. We watch that test fail. We then will write just enough code to pass the test and make that test green. And then we will look at whether there are any opportunities to tidy up our code a bit. Maybe there's a bit of repetition, maybe there's a little bit more than we need, and we can move things out to the places they need to live or condense them down so that our code is as clean as possible. And we can do that refactoring work before we write the next test and make sure that it's not changing any of the behavior. The tests that we have already are still passing. We're just cleaning up our code a bit, and then we'll move on to writing the next failing test for the next piece of behavior that we want to introduce into our program. And as I mentioned, we're going to look at a brief example. It's not going to be anything too in-depth, but just to kind of give an idea of these principles in practice. So we're going to look at a kata called, or kata, depending on how you pronounce it, called FizzBuzz. Kata is a Japanese word meaning form, and it usually refers to when a martial artist will practice choreographed moves alone to continue to hone their skills. In programming, these are a series of small exercises which help programmers hone their coding skills. So we're going to work or start to work on the FizzBuzz Kata just to kind of help to clarify that red-green refactor cycle. So the FizzBuzz Kata is a small program which will, when given a number, give that number back. However, if that number is one which can be divided by 3 as a whole number, it will actually give back fizz. If that number is one which can be divided by 5 as a whole number, we give back buzz. And if it can be divided by both 3 and 5, so for example, the number 15 can be divided by 3 and can be divided by 5, then we'll give back FizzBuzz. And writing a program which allows you to do that for numbers up to 100. So where might we start with that? So I've written this example in Ruby because I find it quite a lot easier to read. So we have our spec file, so that's where our test lives, and this is for our FizzBuzz program. And on this first line, we're requiring our FizzBuzz program. We're saying, look at my FizzBuzz program, and we're describing what that program does, or that unit, I should say, apologies, that unit does. And we have our first test, and we say that that unit returns 1 when it's given 1. And here we're showing that we're giving our unit a 1, and we expect the thing that we get back to be 1. So we've run our first test using this command, and we can see that there's a failure here. So we've got our red test, and the failure is at the point where we require FizzBuzz, and it's telling us that it can't load this file, which is correct because we haven't written it yet. Then we move to making this test green. The first thing we can do is we can define or write our FizzBuzz. We can say it's going to take a number, which we know is going to be 1, and it's going to give back that number, which is 1. And now we can see that we've got 1 test, which is green. We've also got an explanation here that we've got 1 test and there are 0 failures. So that's our first test written. And we look at this and we can see that there isn't much opportunity to refactor this at all. It's quite clean, there's only 3 lines. So we can move on to writing our next test. So our second test says we know that we want, when we have a number that is 3 or divided by 3, we want it to say fizz. So we write our second test to say it returns fizz when given 3. So here we give it 3 and we expect to get fizz back. We run our test suite and we find that we've got 1 test which passes, our first one, and we've got 1 test which has failed. And it will, here in the description, tell us for this particular test, we've got a failure, we had this expectation, but this is what we've got. And it also really helps because it tells us where, on what line. It tells us on line 9, this expectation has failed. And we can also, just to differentiate from the last example, see that we've got 2 tests and 1 of them is failing. Then we can work on making that test green. So we can now say, if the number we've received is 3, give back fizz, else just give back the number. And now we've made our test pass. Again, still not much opportunity here to refactor anything. So now we can start thinking a bit more about these numbers which divide by 3 as a whole number. So we can move on to 6 and we can say, well, I want to get back fizz when I pass in 6. And that again fails because we're only returning fizz when our number equals 3. So in order to make that test pass, we can then say, if our number equals 3 or it equals 6, give back fizz, else give back the number. Each time we're just writing just as much code as we need to write that test. We're keeping it quite simple and we're just passing the test, the specific test we've just written. So that test is passing, it's fine. So we can write our next test. Now we've tested 3 gives back fizz, 6 gives back fizz. We know we want to keep doing that for multiples of 3. So we've written this new test which says it returns fizz when given a multiple of 3. And this time we're passing in 9 and we want that to equal fizz. Again, that test fails because we're only doing that for the numbers 3 and 6 and no others. To get our test to pass, where we're passing in 9, we can say if this number equals 9, then give back fizz. And we've passed this test condition because that's the number we've given as part of our test. We've got these 4 examples here and none of them are failing. But here we have an opportunity. We've got each of these conditions and we don't want to end up with a long list of every possible number that could be divided by 3 in order to make this program work. So here we have an opportunity now to refactor and to make this a bit more true. So this symbol here is called modulo, and that will basically say the number that you've given me divided by this number, how much is left over when you divide one by the other. And if there's nothing left over, so in that it's a whole number, it can be divided by 3 as a whole number, then give me back this. Otherwise, give me back the number. And you can see here, we still have our 4 examples and 0 failures, but we've actually ended up with much with less conditions and less code than we had before, but it's still doing the same job. That's just a brief introduction to getting started with test driving your code, and how you would see that red, green refactor cycle start to work in practice. Now, if test driving your code was something you were interested in doing and you're thinking about how you might get started, I just wanted to touch on what some resources could be to help with that. So we just looked at Kata, and I do really recommend those. Throughout my internship, I found Katas a really helpful way to learn not only about how to test drive your code, but how a specific language works. We did a few of these during my internships, and FizzBuzz, as well as another one called CoinChanger, were probably two of my favorites. You might also think, what testing framework do I start with? What language do I start with? I personally started learning with Ruby, which I found quite easy to read and to write. It doesn't matter which language you start with necessarily. There might be certain languages you want to learn or want to learn next. But once you've chosen a language, look up the testing libraries and frameworks for that specific language and find the documentation around that. I would typically recommend using one of the most popular ones for that language. For example, so with Ruby, you have RSpec and sometimes Rake. With Java, you have something called JUnit. And it's typically a good idea to go with the most popular ones, because when you do get stuck and do have questions, which we all do no matter how experienced we are, it's much easier to find solutions or find examples of where others have tried to do similar things. I have also listed some resources available at this link, and there's a couple of articles in there and some pointers to some more classes that we can look through to see if there's any of those that you want to start with. There is also a tutorial on test-driven development, which goes into much more detail than I've been able to cover in today's session. So do have a look at that. So just to recap, we covered what test-driven development is and the red-green refactor cycle, why we do it. So we talked about writing the test and then making the test pass. For me, thinking back to that conversation about failure, learning test-driven development and getting comfortable with failure has been really freeing in many areas of my life. Whether that's personal challenges of finally learning how to drive or getting serious about a fitness regime, rather than going into it seeing this as a task that's insurmountable, that's going to take a lot of work, that I need to get right the first time. I'm much more comfortable now starting with the smaller, controlled steps which help me over time to reach my goal. So, what's the first thing I can do, and then the next thing, and how do I apply what I've learned going forward as I progress towards that thing I'm working on? We also touched on a brief example of TDD. For me, each time that I learned a new language or concept throughout my internship and apprenticeship, it was like writing a newer test. I really had this fear throughout my internship, especially, that there would be the one thing that I tried to learn that I just couldn't get, and that would be the point where my journey would end and I'd have to give up this dream of becoming a programmer, and it would all be over. But I've learned along the way each time that there is a way to make the test green, and remembering that each time I reach a new hurdle has been really helpful. We've also covered some resources to get you started. And as I mentioned, those are articles, a tutorial, some suggestions of different katas you can work on. But I wanted to add to that to say that my resources have been colleagues, mentors, and peers. Their transparency around what they found difficult when learning and their suggestions for what helped them have been my documentation and my reassurance that, like them, I can continue the journey and keep progressing. And to wrap up, I just wanted to share one quote which I found. I'm not quite sure who it's by. It doesn't seem to point to who said it, but it says, "Failure may change your methods, but not your goals." And just to say thank you so much for listening. Feel free to reach out and to connect via the below methods. And please do let me know how learning to fail goes for you. Thanks very much.